So the last thing I want to mention today is how we can think about electron configurations for ions. It turns out that it's going to be a little bit different when we're talking about positive ions here. We need to change our rules just slightly. So what we know is that these 3d orbitals are higher in energy than 4s orbitals. So I've written the energy of the orbital here for potassium and for calcium. But what happens is that once a d orbital is filled, I said the two are very close in energy, and once a d orbital is filled, it actually drops to become lower in energy than the 4s orbital. So once we move past, we fill the 4s first, but once we fill in the d orbital, now that's going to be lower in energy. So that doesn't make a difference for us when we're talking about neutral atoms, because we would fill up the 4s first, because that's lower in energy until we fill it, and then we just keep going with the d orbitals. So for example, if we needed to figure out the electron configuration for titanium, it would just be argon, then 4s2, and then we would fill in the 3d2. So actually, we don't have to worry about this fact anytime we're dealing with neutrals. The problem comes when instead we're dealing with ions. So what I want to point out is what we said now is that the 3d2 is actually lower in energy. So if we were to rewrite this in terms of what the actual energy order is, we should instead write it 3d2, 4s2. So you might ask in terms of when you're writing electron configurations, which way should you write it? And we'll absolutely accept both answers for a neutral atom. They're both correct. In one case, you decided to order it in terms of energy, and in one case, you decided to order it in terms of how it fills up. I don't care how you do it on exams or on problem sets, but you do need to be aware that the 3d, once filled, is lower in energy than the 4s. And the reason you need to be aware of that is if you're asked for the electron configuration now of the titanium ion. So let's say we're asked for the +2 ion. So a +2 ion means that we're removing 2 electrons from the atom, and the electrons that we're going to remove are always going to be the highest energy electrons. So it's good to write it like this, because this illustrates the fact that, in fact, the 4s electrons are the ones that are higher in energy. So the correct answer for titanium +2 is going to be argon 3d2, whereas if we did not rearrange our order here, we might have been tempted to write as 4s2. So keep that in mind when you're doing the positive ions of corresponding atoms. All right, so we'll pick up with photoelectron spectroscopy on Wednesday. Have a great weekend.